Hello everyone and welcome to the Build at Scale Lab. In this video, we will be reviewing integration techniques with FetchCore and Node-RED. First, we will program a button to trigger an action group in FetchCore to tell the AMR to pick up the cart and go to a manual station. The AMR will wait at the manual station until the operator presses the second button that we will program, and the AMR will drop the cart back off at the original location. Finally, we will program a flow to interpret the data coming out of FetchCore into Node-RED. In the context of the overall lab objectives, this will be important as this is the signal that will trigger the cobot to unload the cup off of the cart.
All right, so let's start in FetchCore. We'll set up our map and then our action groups and workflows. So to set up our map, I know that we're going to have to pick up the cart over here somewhere. So I'm going to go to Edit Annotations. Let's go to Position and then Freight 100 cart position. And I'm pretty sure it's around here somewhere, but I don't know exactly where. And then we want the AMR to bring the cart over to the manual station, which is around here. But again, I don't know exactly where. It's somewhere around here. We want this facing this way. Now, the reason I am not having this point be a cart position and instead I'm using a regular robot position is because the cart positions are for either picking up and dropping off the carts, but because we want the AMR to drive over here and keep the cart on while the manual station does its operation, we have to use a regular position and not a cart position because cart positions are just for picking up and dropping off carts. And then the last thing that I'll add is just I'll add one extra point just sort of as a waypoint to reset things. So the flow will go, the AMR will go here, and then it'll pick up the cart, bring it here. Once manual operation is done, drop the cart off here, and this will just be one last point for the AMR, just sort of sit as a waypoint. So I will just label this as waypoint. I will label this as manual station, and I will label this as cobot dock 1, because it's next to the cobot for loading and unloading. So again, I don't know the exact position of these locations. I know it's somewhere around here, but it could be here, it could be here, it could be here. Same thing with this manual station. Point, I don't know exactly where this should be, and it's a fairly precise location. So you can either do a lot of guess and check and just like move it and have the AMR go there and then move it again and then rinse and repeat until you get it exactly where you want. But there's a smarter way to do it that I will show you right now. So the smart way to do it is to use the joystick to position the robot exactly where you need it to and then go back and look at the map on FetchCore and place the annotation right on top of the robot. So now that I have driven my AMR to exactly where it needs to be, I can use my AMR as a reference point and then move my cart position to right over the robot. Get it lined up just right. And that should be pretty spot on. I can publish that. And now I will do the exact same technique for the manual station. All right, so I have positioned the AMR where I need it to be for the manual station. So I'm just going to take my manual station position and just line it up with my AMR. The orientation just right. That should be close enough. So I'm just going to hit publish, and we now have an accurate map. Now that I have my map accurately set up, let's program the actual workflow. So I will go to New Workflow, select the right map, and then in the workflow name, let's call this cobot dock to manual, because you're driving the AMR to the cobot dock, picking up the cart to the manual station, and then back. And for the action group, I'll just name it the same thing, cobot doc to manual. Great. Now, in terms of the type of action group, we don't want this to run when it's scheduled, right? We want it to run when it's triggered. So I'll change this to on trigger, and then I'll say using trigger schema. And we actually don't have any trigger schema set up because we haven't set those up yet. We'll do that next. But in terms of the actual workflow logic, the first thing that we want to do is pick up the cart, right? So let's go to the cart connect, pick up cart, at cart position, cobot doc 01. Great. The next thing that we want to do is drive to the manual station. So we'll go to navigation, go to position, manual station. Great. All right. Now there's two ways to do this next bit, because once we're at the manual station, we want to wait for a trigger to then tell the AMR to drive back and drop the cart back off at the cobot dock, right? So there's two ways to do that. The first is using the integration tab and say wait for a trigger. And then after that trigger has been activated, we will then go to cart connect and say drop off cart at cobot doc 01. And then we will have it navigate to afterwards, just once it's exited the cart, go back to the waypoint. So that's the first way to do this. The other way to do this is by making a second action group and having this also be on trigger and making a second trigger and then just triggering these two separately. Just for simplicity's sake, I am going to just do this in a single action group, but you could do it the other way too, and it would be totally valid. So we have the logic programmed for how we want the AMR to behave with the triggers. We just haven't actually programmed the triggers yet. So let's go do that right now. To program a trigger, you should go to the Triggers tab, and then we'll click New Trigger Schema. We'll name this trigger schema, we'll just say it is the doc to manual trigger. So I'll make two triggers, one to tell the AMR to take the cart from the dock to the manual station, and then we'll make a second trigger schema to tell the AMR to take it from the manual station back to the cobot dock. Make sure we need to select the right map, and then we will hit this new predefined trigger button. This is what will actually give you the trigger URL that you can activate. And then you have to name this trigger, so I will name this one doc to manual. Great, so I will just save this. And then I will create a second one. I'll call this manual to doc. Select the right map. Same thing. Manual to doc. Great. Save this as well. Okay, so now if I go back to my workflows, we have this on trigger, and we want to trigger it to go from the dock to the manual station. And then here we want to wait for the trigger manual back to the dock. All right, now I should be able to save this. And that should be our workflow programmed. All right, so we're all ready to go. Now the only question is, how do we actually trigger these triggers? So if we go back to the Triggers tab, and let's go find our triggers. So for example, the manual to dock, and we'll start with the dock to manual. So if we look at this trigger and we hover over this little icon, it says FetchCore generates a unique endpoint URL for each predefined trigger. You can call this URL with a post request. So basically what this means is that they've given us a URL, and we can just hit this URL and it will activate the trigger. So if I hit this copy URL button, I can actually just toss this into my web browser and see what response I get. So it gives me this response, basically just telling me that I'm not authorized and that I need to include authorization in the header with a valid token. To explain what's going on here, I have pulled up a graphic that contains the 4 parts of an HTTP request. An HTTP request is consistent of a URL, method, headers, and body. And we need to make sure that all 4 of these are exactly as FetchCore is expecting them to be in order for our trigger to function the way that we want it to. So the URL, we know what the URL is supposed to be. FetchCore generated a URL for us saying, hit this endpoint for your trigger. So we have the URL. That's good. And for the method, we know what the method is supposed to be because Fetch told us it says call this URL with a post request. So we know the URL, we know the method, and but when I tried calling it in the browser, we got this. And this is saying that we must specify authorization header with a valid token. So what this implies is that in our header for our request, that we need to make sure that we include proper authorization. So when we're making these kinds of requests to a private server, right, that's not just going to let anyone on the internet hit this endpoint, you need to make sure that you provide proper authentication. And this can look like something as simple as a username and password. In FetchCore, they use something called a bearer token. Basically, you can use your username and password and a couple other things to generate this really long key that you can include in your header that will then make sure that when FetchCore gets that request, it can authenticate and make sure it'll match up its key with your key and say, yep, okay, this person is authorized, and we will go ahead and process that request. So if you get these 3 things correct, FetchCore will process your request. And the body is just where you can include extra data about your request. However, in this particular instance with FetchCore, because of our triggers, we don't actually need to include anything in the body of the request because we're just hitting the endpoint, and that's giving FetchCore all the information it needs to just activate the trigger. We don't actually need to pass anything to the trigger itself. So in order for FetchCore to accept the trigger, the body actually needs to be completely blank on the HTTP request. So we just need to make sure that we are providing the right URL, method, and that we include the right authorization in the header. And so to do that, now we will actually move into Node-RED. Now let's make this HTTP request to FetchCore to hit that trigger. So I'll start off with an inject node, and then I will find the HTTP request node here. Link that up, and then I will take the response and just simply output to the debug window. Now to configure the HTTP request, we'll open this up. For the URL, we can go to FetchCore and copy the URL for the trigger. Copy this right here. Paste that into the URL. And for the method, we know from FetchCore it's supposed to be a post method. So we'll change method to post. Now if we hit done and we deploy this, if I inject a timestamp here, you can see here we get exactly the same error that we do as when we just simply put that URL into Chrome, right? Basically just saying that we are unauthorized because we haven't added authorization yet. So in order to make sure that we're authorized, we can go in here and click this little use authorization check mark, and then we'll use bearer authentication. So you need to include this token. Now, don't worry about how to get this token. We will provide this token for you. So you should have a little comment box when you get to lab here in your flow. You'll just double click on that, open it up, Control A to select the whole thing, Control C to copy it, and then you can just Control V it right into the token field. And let's hit done. Okay, now when we deploy this again, and I hit inject, now you can see it's a different error now. So what's going on here? Basically, this is FetchCore telling us that, hey, you sent me some stuff and I don't know what to do with it, so I'm throwing a fit. So remember how before I mentioned that this body section needs to be completely empty? Well, that's what's going on here, is when we're injecting this timestamp, we are setting message.payload to this timestamp. So That's just the basic default behavior in Node-RED. So you can actually see what's coming out of this timestamp node. I'll just put this to the debug window as well. So when I inject this, what's happening is this is what we're sending as a payload to FetchCore. And it's like, I have no idea what to do with that, so I'm going to throw an error. Now, there's two ways that we can deal with this. The first way to deal with this is to just make sure that, you know what, we're not going to send anything in the message.payload, because it's the message.payload that is being sent as the body of the request, and that's just simply how the HTTP request node works. So if you click on a node and then you go to the documentation, it will tell you that the payload is sent as the body of the request. And like I said, we need to make sure that there is no body in the request in order for this to work properly. So I just deleted message.payload out of the inject node. So now when I go to make this request, let me deploy this. Now, that's actually FetchCore's way of saying, yep, you successfully hit that trigger. So we are hitting the trigger now, so that is good. Now, that is the first way to make sure you clear the body of the request to send. There is a second way that's a little bit more versatile. So you can either just make sure, but basically you just have to make sure that the message that's going into the HTTP node has message.payload set to null, so it just doesn't exist. So you can either clear it here from the properties window, or let's say you just have, maybe you do have some sort of message.payload and you need to make sure you clear it before it gets to the HTTP request. A really easy way to do this is just grab a function node, open this up, and then we will just say message.payload equals null. Done. This just clears the payload. So if I deploy this, even though I actually give it a message.payload, this will just delete it, right? And so if I inject this, you can see it still works. So now that we know how to successfully hit one of these triggers, let's build out the rest of the Node-RED flow. So we're going to do this with two buttons for the two different triggers. So I'll make sure I name this HTTP request node. I'll name this one. This is doc to manual. And then the other HTTP request node, copy and paste this. The other one was manual to doc. Manual to doc. And it was a different endpoint, right? So I'm going to go back to FetchCore and say manual to doc and grab this URL, go back to Node-RED and paste that in. Now the authentication works for both of them, so I just need to make sure that I grab this again and paste it in. Even if you copy and paste the node from here to here, for example, it actually will not copy the authorization with it. It will keep the URL, but it won't copy the token with it for security purposes. So just make sure every time you make a new HTTP request node, you will have to type that token or copy and paste the token back in. I would not recommend typing it out. So we've got our two HTTP request nodes. So we're going to make two buttons for them, right? So let's go down to the dashboard. So we're going to make a button and a second button. So we'll just add this to the home page, and we will label this, we'll just call this manual to doc button, and then it will send a payload. I don't think we can really avoid it sending a payload based off of how the this node is configured, but what we can do is get around that using this technique here. So this will clear out message.payload. So we'll just do the exact same thing here. Make sure that message.payload gets cleared. Put it on the home screen, and we'll call this manual. Actually, we'll call this operation complete. This will be for the operator at the manual station to hit this button when they're done. All right, so we'll move that here, just organize this a little bit. Connect these. And have the output go to a debug window. Now, the last thing that we need to do is, because if we trigger these, nothing's actually going to happen. And that is because we don't have this workflow that we created, this cobot doc to manual. This is not actually scheduled, right? So right now it's a Monday, and we actually have this demo loop running. So I'm actually just going to delete this. I'll delete this one as well. And I'm going to create a new schedule item. And I'm going to make sure that the cobot doc and cobot doc to manual workflow is running. I'll hit next. I will run it starting at 2:38. It is currently 2:37, and it'll run for an hour. I'll just make this run for 2 hours. And hit next. Make sure we assign our action groups to Jerry. He's a cart connect robot, and then we'll go next and save schedule. Great, so now this is scheduled, and it is currently 2:38. That workflow, the cobot to manual workflow, this is live. So if we hit these triggers, the AMR will actually perform this workflow.
All right, so we've got our flow pulled up here with our two buttons. We have manual to dock and then operation complete. Let's start with this button and see what happens. So as you can see here, the AMR was supposed to be facing the other way. So it went to the right point, but it's facing 180 degrees the wrong direction. So we're going to fix that by adding a rotate 180 degrees command into the workflow.
Right, so the AMR went to the correct point on the map, but it's facing the wrong way. So even though the position, you can see like this robot position, you can see it has an orientation. Like this, it's facing this way, but for some reason, sometimes AMRs will park not respecting the orientation, even if you tell it to position unidirectionally. So the way we can fix that is in the flow itself, you will go to the workflow. And then once it picks up the cart and then goes to the position manual station, we can tell it to rotate. So we will rotate clockwise at 180 degrees, and then 5.7 degrees per second is just painfully slow. So we're going to crank that up to 25 degrees a second. Oh, and a second thing that we're going to do is do one other edit, which is on this cobot dock position. We need to specify that we want the cart orientation during drop-off to be retained from the pickup orientation. So when the AMR drops the cart off, the fixture that's holding the cup will be facing the cobot. And if we can accomplish this by having it drop it off in the same way that it picked it up. And then the one other change that I made was on the Node-RED flow. I switched this button to be appropriately labeled. We're telling it to pick up at the dock and then drive to the manual station, not manual to dock. That's the other flow here. So my bad. I just fixed that, and now we should be good to go.
All right, so we've reset everything. We have our Node-RED dashboard with appropriately labeled buttons now. So I'm going to hit the dock to manual button. And the AMR should come pick up the cart. And there's the rotation. Perfect. All right, so we're going to pretend we're at the manual station. Pick up an item, put it in the cup. Then we're going to hit operation complete. And the AMR is driving back to the cobot dock position. And it should park in the correct orientation. Yep, there it goes. Now all that's left is for it to drive to the waypoint. And that's the whole flow. So the flow is working. There's only one thing left that we still have to do. And that is get a signal out of FetchCore back into Node-RED to let us know when the AMR has successfully dropped off the cart. We need to know when the AMR has successfully dropped off the cart so we can tell the cobot to start the program to pick the cup off of the cart and load it back on the desk. To do this, we're going to use webhooks. Webhooks are just like triggers. However, instead of Node-RED sending an HTTP request to FetchCore, which is then authenticated and processed by FetchCore servers, we're going to have FetchCore send our server a request, which we can then handle. In order to do this, we need to set up a server that's exposed to the internet that FetchCore can send a request to. We have already done this, and we have that server forwarding all traffic to the Raspberry Pi that we have running Node-RED.
All right, so let's first handle the FetchCore workflow side of things. We have our action group already set up to, on trigger, send the AMR to pick up the cart at the cobot dock, go to the manual position, and wait for the trigger to then bring it and drop it back off at the cobot dock. And this is where we want to send that webhook and send that signal back to Node-RED, so Node-RED can then send the signal to the cobot to unload the cup. So this is where we want to put that signal. To do that, it's pretty straightforward. You just have to go to the integration tab, and then we can grab this send webhooks block and then just snap it in place right there. I already have this webhook pre-configured, but you can send it with any message you want. So we'll just send it. It'll say cart arrived. Great. So yeah, this webhook is already pre-configured, but we can kind of dive into the settings a little bit. Under this webhook tab up here in the top left, go here, and then webhooks are really straightforward to set up in FetchCore. All you have to do is give them a name, and then you have to point them at the URL of your server. So this is the URL of our server that's publicly exposed to the internet, and so FetchCore is going to send the request there, and then that server is then going to forward it to our Raspberry Pi, which is here on our local network and is running Node-RED at this port. So this webhook will be used to send a request to our server at this URL, which will then forward the request to this address on our Raspberry Pi at this port. And this is where we're going to catch that webhook and then respond and then use the data from the webhook in the rest of our logic. Okay, so now let's handle the Node-RED side of things. So Node-RED, we need to accept the incoming request and then process it, return a response, and then execute whatever logic we want to. So it's pretty straightforward. We need to grab the HTTP in node to handle the HTTP request. And now let's take a look at the properties. So we can say what kind of property we want to process, what method we want to process. We want to process post methods with the URL. And how we know what to use for this is if you go back in and you look at your FetchCore webhooks page, you can see at the end of the URL we have the /webhook. That could be whatever you want it to be. That could be /my AMR endpoint or whatever you want. But I just chose /webhook. And if you go into Node-RED, this is where you would say, I want to listen to /webhook. So this will process post requests at /webhook, which is what our webhook is. Great, okay. So now when we send a trigger to FetchCore using a HTTP post method, we expect a response back from FetchCore that we can then print out at the debug window so we know that our request worked. So FetchCore expects the same behavior. So if we don't return something to FetchCore, it is going to assume that the webhook was never delivered, and it will not continue on with the flow. So if we look at our workflow, unless we respond with a successful response after we get the webhook, then it will never actually execute this last step to go to the position, and this action group will get frozen, basically. So we need to return a response, which we can just simply wire up like this. So once we get the request, it will immediately execute a response. The default behavior of this will be that it will send a status code 200. You can see over here in the documentation, it will set the status code to 200. 200 is basically the default value saying everything is good, which FetchCore is waiting to hear back so it knows it can continue. So what we're going to do is just return that response and then also output to the debug window. Now let's deploy this.
All right, so I've got Node-RED pulled up on my iPad here. This is the same flow that we were just looking at on the computer. So I've got that pulled up in one tab. In the other tab, I have our UI. So I'm gonna go ahead and start the flow with the dock to manual button. The AMR should come and pick up the cart and then bring it over to where we've designated the manual station. Okay, so that sometimes happens. Basically, the AMR just failed to find the right spot under the cart, so it's just going to try again. There we go. Now it got the cart, and it should take it to the manual station. All right, now I'm going to hit the operation complete button. That should bring the AMR back. And while that's happening, you can see in the debug window, there are the responses from FetchCore for our trigger requests to the FetchCore servers. And now, once the AMR has successfully dropped off the cart, we should see that webhook from FetchCore sending us a request come through also in the debug window from this flow down here. So there we go. We should be hitting that point in the flow, and there it is. That is the webhook that we got from FetchCore. So let's take a closer look at that on the computer.
All right, so I'm back on my main computer here, and let's take a closer look at the data that we got from the webhook. So these are us sending an HTTP request to FetchCore for what they call a trigger. And then this is FetchCore sending an HTTP request to us. And this is the debug from what we got from FetchCore. So if we open this, the first thing you can see is our message here that says cart arrived, which we specified in our workflow right here. So that's pretty cool. But also, if you want to dig around a little bit in here, you'll find a bunch of really useful data depending on what it is that you're programming. You can discover whether or not the AMR is mislocalized, if it's in low battery, what map it's using, if it has any error states, the last time that it was booted, the last time it was charged. There's a bunch of information in here that could be useful to you depending on what kind of logic you need to execute. But for now, that's going to be all, because really all we need is this message that comes through, that event, and then instead of a debug node, we could put something here that tells the cobot arm to unload the cup off of the cart or whatever we want to do. But for now, that concludes this video. So thank you very much for watching.